Hello students. Today I am going to discuss about the examples on Newton's interpolation formula. Here I am going to solve a problem. Again, I have taken this from the question bank. I'm going to upload the question bank today. By tonight I'll upload in the Google Class. I'll consider this problem, of course, is taken from question bank. It is here I have made use of both Newton's forward interpolation formula as well as backward interpolation formula. Here the example says like this, goes like this. Given that f of 40 is 184, f of 50 is 204, f of 60 is 226, f of 70 is 250, f of 80 is 276, f of 90 is 304. You are asked to find f of 38 and f of 85. Carefully, if you observe this, see, f of 38, I want the value of the function at x is equal to 38. My table starts with x is equal to 40. That means this 38 is near the beginning of the table, right? 85, the second one is 85. I have to find out the value at x is equal to 85. So if you look at the table, the last value is f of 90. That is the value of the function at x is equal to 90 is given to you. That means you are required to find out the value when x is at the end of the table. So that's why I have considered both the cases here. Here we are using, in one case we are using Newton's forward interpolation formula. In the other case we are using backward interpolation formula. So here if you observe, see, that's what I have written here. So note, always if the non-tabular point lies at the beginning of the table, we use Newton's forward interpolation formula. If the non-tabulated point lies at the end of the table, then we use Newton's backward interpolation formula. Right. Now, in this case, 38 lies at the beginning of the table. Therefore, I use Newton's forward interpolation in evaluating f of 38. Similarly, I use the backward for f of 85. So that's what I have written here. Now, what are the various steps involved in solving the this for finding out the values, right? Now I first form the difference table, right? As I told you, difference table is what I consider the first order difference, second order difference, third order difference, and fourth order difference. See, I have told you in one of the earlier classes. See, I am having totally how many values here? 1, 2, 3, 4, 5, 6 values of x. That means I can maximum go up to del raised to 5. That is fifth order difference. I can go up to. Right. Now I write the table like this. In the first column, I write the value of x. In the second column, I write the value of y. Right. The corresponding values. So for x is equal to 40, y is 184. For 50, it is 1204. For 60, it is 226. For 70, it is 250. For 80, it is 276. And for 90, it is 304. So like that, x0, x1, x2, so on up to x5 values are there. Corresponding y values are there. Right. Now I write the first order difference. That is y1 minus y0. That will be my first order difference. So 204 minus 184, 20. 226 minus 204, 22. 250 minus 226, it is 24. 276 minus 250, it is 26. 304 minus 276, it is 28. See, now if you look at this value, see what is this 20? It is y1 minus y0. So what is this? The same value y1 minus y0 is forward difference for y0, because what I did, I considered y1 and I found out the difference of y0. That means I considered the forward value of y0 and I found out the difference. That means it is forward difference for y0. The same is backward difference for y1. That's why this 20, see, it is same. That is forward, this 20 is what it is, forward difference for y0 and backward difference for y1. On the similar lines, 22. 22 is what? It is y2 minus y1. That means 22 is forward difference for y1 because it is y2 minus y1. So I considered forward value of y1, right? Then the same is backward difference for y2, that is nabla y2. Similarly, y3 minus y2 is del y2, del 3 minus uh, that is y3 minus y2 is del y2, forward difference for y2, and del y3 minus y2 is backward difference for y3, right? So the same table, the differences table can become forward difference, can act as the backward difference also. Then the what is the second order difference? The difference of the first order difference gives me the second order difference, that is 22 minus 20, it is 2. 24 minus 22, it is 2. 26 minus 24, it is 2. 28 minus 26, it is 2. Right? So, if you look at this, see, 22 minus 20 is what? It is del y1 minus del y2. That is forward difference y1 minus forward difference of y0. Therefore, this is second order difference of y0. So, this 2 is second order difference for y0. So, del squared y0. Del y2 nabla y2 minus nabla y1 is what? It is backward difference for nabla y2. Therefore, this 2 will be nabla squared, second order backward difference for y2. On the similar line, these two, del y2 minus del y1 is forward difference for y1, second order forward difference for y1. The same is second order backward difference for y3. Similarly, del squared y2 is 2, nabla squared y4 is 2, del squared of y3 is 2, nabla squared of y5 is 2 again. So if I go for the further differences, all these are zeros. So the first del y1, del squared y1 minus del squared y0 will be del cube of y0. Del squared y2 minus del squared y1, that is difference of the second order difference. So it is del cube of y1. Del squared y3 minus del squared y2 is del cube of y2. The same is nabla cube by 3, nabla cube by 4, and nabla cube by 5. See, if you observe, see, for the forward difference, see, top diagonal, top to bottom diagonal, if you consider for forward difference. See, the first value is y0, second value, second column, del y0. The third column, del squared y0. The fourth column, del cube y0. The fifth column will be del raised to 4 y0. If you consider backward, see y5, the bottom to top diagonal, the bottom value, first column, y5, next value, it will del raised to, it will be del of nabla of y5, next one, nabla squared of y5, next one, nabla cube of y5. Like that, your bottom to top diagonal will be same when you consider backward difference. If you consider forward difference, the top to bottom diagonal will be same. So this is how we form the forward difference table. Now I go to the step 2. So whenever you have to use Newton's interpolation formulae, first you should form the difference table. You should write down the difference table. Maybe this is for forward difference, or maybe that is backward difference. And later on in the next class, you will come to know about divided difference also, right? So your first step is what? Whenever you come across Newton's interpolation, either Newton's forward interpolation, or Newton's backward interpolation, or Newton's divided difference interpolation, in all these three cases, first step is what? I should write down the difference table, right? Corresponding difference table. If you are using backward difference, you should write down backward difference table. If you are using the forward difference, you should write down the forward difference table. And if you are using Newton's divided differences, then you have to write down the divided difference table, right? So again, I need not tell that the forward difference table and backward difference table, numerically they will carry the same value, right? So the forward difference of y0 will be the backward difference of y1. So they both are same. Forward difference of y1 will be the backward difference of y2, like that. So the numerically forward difference table and backward difference table, they are one and the same. Only the notation or the position of their nomenclature changes. That's all, right? What is the step 2? The second step is what? I should choose a suitable interpolation formula. So as I told you earlier, if the non-tabular point or the point at which I have to calculate the functional value, if it lies at the beginning of the table, then I should use forward difference formula. If the non-tabular value, tabulated value, lies at the end of the table, then I should use Newton's backward difference formula. So now I consider the first case. For x is equal to 38, I should find out what is f of 38. Right. Now, if I look at x is equal to 38, it is at the beginning of the table. In fact, it lies outside the region. It is actually not interpolation, it is extrapolation. Anyway, we use the same formula, but it is actually, in the real sense, it is extrapolation because it lies outside the range of 40 to 90. Right, because it is less than 40. Right, now, what is the Newton's forward difference formula? F of x naught plus ph is y naught plus p times the forward difference of y naught plus p into p minus 1 by 2 factorial second order forward difference of y naught, that is del squared of y naught, plus it is p into p minus 1 into p minus 2 by 3 factorial del cube of y naught. I don't write those things because del cube of all values are zeros. Third order differences are zeros here. So now I know del y naught, I know del squared y naught from the table. So del of y naught is what? Del of y naught, see y naught is 184, del of y naught is 20, del squared of y naught is 2, del cube is 0. That I know. So I know in this formula, I know y naught, del y naught and del squared y naught. Now my aim is to find out the value of p. I know x naught plus ph is x. That is x is equal to 38. So x naught plus ph is 38, x naught is 40, h is 10. The common difference here, see, I consider any two consecutive xi's, find out the difference. That gives me the common difference. So h is 10. Therefore, if I substitute in this equation, 40 plus p times 10 is 38, or p times 10 is 38 minus 40, it is minus 2. So p is what? Minus 2 by 10 or 0.2. So I got the value of p. Now what is my next step? I should substitute the values here. So I know the value of y naught is 184 plus p is what? Minus 0.2. So 0.2 times del of y naught. Del of y naught is 20 here. So I write that value. Del of y naught is 20 minus 0.2 times 20 plus p into p minus 1 by 2 factorial. 2 factorial is 2 only. Times del squared of y naught. Second order forward difference of y naught. That is minus 0.2 into minus 0.2 minus 1. It will be minus 1.2. So that divided by 2 factorial is 2 into 2. So these two cancel here. So if I simplify this, what I get? It is 184 minus 0.2 times 20 is 0.4. It is 4. Then 0.2 minus into minus 1.2. So that will be equal to plus 0.24. So if I simplify this, I get 180.24. So f at x is equal to 38 is 180.24. Now I consider the second case. That is, I have to find out y at x is equal to 85. So now if you look at x is equal to 85, it clearly it follows that it lies at the end of the table because the last point is 90, right? That is x5. So it lies before that, right? So now I have to find out, since it is at the end of the table, I should use Newton's backward difference formula. So what is Newton's backward difference formula? It is f of xn plus p times h is equal to, this is my x, right? Xn plus p times h is my x. So is equal to yn plus p times nabla yn plus p to p plus 1 by 2 factorial nabla squared yn. So what is nabla and nabla squared and all? So the same value. Nabla of yn is 28 here. Nabla squared of y5, because n is 5 for me, the last value of the table. So n is y5, that is n is 5. So y5 is 304. I have to make use of this. Then nabla y5 is 28. Then nabla squared y5 is 2. Nabla cube and all are zeros. So I make use of these values here. So now here, if you look at, I know yn, that is y5. I know the nabla yn, that is nabla y5, and I know nabla squared of yn. Right. Now I have to, next step is what? I should find out p. P is what? I make use of this. X is what? X is xn plus ph. X is 85. So 85 is x5 plus ph. X5 is what? X5 is 90. This value, the last value, X5 is 90. So I use that here. So P is what? X minus Xn by H, that is 85 minus Xn is 90 by 10, that is minus 0.5. So if I substitute the value of P and Yn, nabla Yn and nabla squared Yn, I get this value. Yn is 304 plus minus 0.5 is my P. So minus 0.5 times 28, then plus minus 0.5 into minus 0.5 plus 1 in divided by 2 factorial is 2 into nabla squared yn is 2, y5 is 2. So 2 cancel. So what you get? 304 minus 14 minus 0.25. So the final answer is what? It is 289.75. Therefore, my so the answer will be what? F of 38 is 180.24 and F of 85 is 289.25. So like this, I can use Newton's forward interpolation formula and Newton's backward interpolation formula to find out the value of F at x is equal to 38 and at x is equal to 35, right? So this completes the solution of this problem. So on the similar line, you try other problems pertaining to Newton's interpolation formulae in your mm, question bank, because the questions from question bank will be there in your last test. Right? Have a nice day.